You. So today, I'm going to show you a really exciting topic in calculus called the mean value theorem. I love it so much, I even have it on my t-shirt. So, let's open to our notebook. Notebooks open, everyone. And I'm going to show you what the mean value theorem is. Guys in the back, please stop talking. Okay, so, let me explain what the mean value theorem is graphically. After that, we're going to look at it algebraically. So, let's say we have a graph. Here are our axes. Here's the x-axis, here's the y-axis. And let's take a look at our graph. How's that? Beautiful graph. F of x. And here, when we take the derivative of something, we're finding the slope of the tangent line. Essentially, the derivative is the tangent line, the slope of the tangent line at all points on a given curve. So, let's draw a tangent line to this graph. But what the mean value theorem states is that while this is our tangent line, there's also somewhere on the graph where there is a secant line that has an equal slope. And what is a secant line? A secant line is a line that joins 2 points in the graph. And it is allowed to intersect. So we can label this secant line. No, it's not a secant line. No, it isn't a secant's line. It's a secant line. And the secant line, if you look at it on the graph, the slope of the secant line is equal to the slope of the tangent line. So let's say that this is an x value of c, this is an x value of x equals a, and this is an x value of x equals b. So what the mean value theorem states is that on a graph there is a point c, at which the slope of the tangent line is equal to the slope of the secant line. I hope that all makes sense. Now I'm going to show you what this means algebraically. We have this equation that you're going to use to solve all problems relating to the mean value theorem. F prime of c is equal to f of b minus f of a over b minus a. And hopefully these formulas look familiar to you. What is f prime? Mandy? Mandy, you don't know? Okay. F prime of c is the derivative of the function f at point c. That is the slope of the tangent line at point c. And Kelly, do you know what f of b minus f of a over b minus a is? Do you? Do you? No? Jerry? Jerry? You think you're smarter than the teacher? Okay. So f prime of c. This is the instantaneous rate of change. So if you look at this in a different way, Jerry, now do you know what f of b minus f of a over b minus a is? You do? Average rate of change? Yes! Great job, great job. This is your average rate of change. And f of b minus f of a over b minus a is the average rate of change. It's the slope of the secant line. So what we're looking at is the slope of the tangent line is equal to the slope of the secant line. And this is what it is algebraic. This is what it is graphically. That is what the mean value theorem states. Let's look at two conditions that you must meet at all times to use the mean value theorem. Otherwise, there is no point C, at which f of b minus f of a over b minus a equals f prime of c. So, let's rewrite that formula again. You're going to need to commit it to memory. Over b minus a is equal to f prime of c. But, to use this formula, f of x must be both continuous and differentiable. If your function does not meet both of these conditions over a given interval, a to b, then you cannot use the mean value theorem. So, let's take a look at an example of how we're going to apply the mean value theorem. This is going to be example number 1. Everyone paying attention, taking notes? Good. So, example 1. F of x is equal to 3x squared minus 6x plus 4 over the interval 1 to 3. So what the question wants you to see is find a point C between points x equals 1 and x equals 3 at which the slope of the tangent line is equal to the slope of the secant line. So we're going to use f prime, we're going to find f prime of C, which is 6x minus 6. We're going to use the power rule, right? That's one of my favorite rules. And we also have to find f of b minus f of a over b minus a. Oh, excuse me, this should be a c. So we have to plug in 1 and 3 into the equation. So 3 times 3 squared minus 6 times 3 plus 4, that's f of 3. This is equal to 27 minus 18 plus 4, which is equal to 13. And we're also going to find f of 1, which is 3 times 1 squared minus 6 times 1 plus 4. This is equal to 3 minus 6 plus 4, which is equal to 1. So we're going to find 6x minus 6. We're going to set that equal to the average rate of change, which is 13 minus 1 over 3 minus 1. Because f of 3 is 13, f of 1 is 1, and then we find b is 3 and a is 1. So we get 6c minus 6 is equal to 12 over 2. 6c minus 6 is equal to 6. 6c equals 12. We get that c is equal to 2. That is a great answer because at this point c equals 2, which is between 1 and 3, that is where the slope of the tangent line is equal to the slope of the secant line. We also have to make sure that this is both continuous and differentiable before we put this answer on our exam. It is continuous and differentiable. We can find the derivative exists, it's continuous, which means that the limit as x approaches a number from left to right is equal to the function value. So it is both continuous and differentiable, and thus our answer is good to go. Let's take a look at another example. Also, have you guys studied for your vocabulary quiz on the Great Gatsby? So, example number 2. F of x is equal to x plus 4 over x minus 1 over 0 to 2. And remember, you can always look on my shirt if you're missing the formula for the mean value theorem. So I'm going to start, and I want someone in the audience to yell at me when I'm going to make a mistake, because knowing me, I'm a little forgetful. I tend to make mistakes sometimes, so please yell at me if I make a mistake. So first we're going to find the derivative, f prime of x, which is x minus 1 squared. We're going to use low d high minus high d low over low low. Quotient rule, right? We're going to do x minus 1 minus x plus 4. Stop! Please don't do that. It's disrespectful to yell at the teacher. Oh, I'm so silly. Okay, so 1 is on the given interval, and if we plug in 1, if we find f of 1, we're going to get 1 plus 4 over 1 minus 1, which is equal to 5 over 0, which means that our function is not continuous. Therefore, there is no c value for this graph between 0 and 2, at which the slope of the tangent line is equal to the slope of the secant line, and thus we cannot use the mean value theorem. Not continuous, not differentiable. So, like I said, and I reiterate, it is extremely important that when you do these problems, you make sure that the graph is both continuous and differentiable over the given interval. It's f prime of c is equal to f of b minus f of a over b minus a. And good luck on the AP exam. Thank you for your time.